Okay, as with all the other two practices that were done beforehand, this play, pause it recording, you're going to be presented with a problem for you to try. And once you've presented an answer and to play, pause it, you will then see me go over it. And so you can check to see if you had done it correctly or not. So here we go. In each of these, you're going to be asked to factor these completely. And so this one here, factor this polynomial completely. When I look to factor polynomials completely, I'm just trying to see if there's anything that can be basically divided out of all the terms of the polynomial. And in some cases, if I have some quadratic polynomials, I can see if I break it down further. Ideally, I would like to be able to get this factored into nothing but degree 1 binomials at the most. However, sometimes that's just not possible. It takes some practice to know whether it's possible or not. But for this, when I'm going to factor something, I need to look at the two terms and be able to find their greatest common factor, something we talked about in week 1. So for this here, I got to think of, okay, well, I have coefficients of 48 and 84, so I got to think of a number that will divide out of both of those. And I want to find the largest one, preferably. X to the fourth and x squared, I got to determine what power of x can divide out of both of those. And the same thing with y to the third and y to the fourth. And so the biggest number, as far as factor out of 48 and 84, is 12. I can factor out an x squared, because that's the highest term I have over here. I can factor an x squared out here and be left with some. And I can factor a y cubed out of both of them. So the greatest common factor here is 12x squared y cubed. And so now I'm going to factor that out. And so I'm basically going to divide each one of these. 48 divided by 12 is 4. X to the fourth divided by x squared is x squared. And y cubed divided by y cubed is 1, so I'm not going to write that. So when I carry through that division, I get 4x squared. And then I'm going to do negative 84 x squared y to the fourth divided by this. Negative 84 divided by 12 is a negative 7. X squared divided by x squared is 1, so I wouldn't write that. And y to the fourth divided by y cubed is y. So I end up with a minus 7y. And that is factored completely. Can't break it down any more than that. So for this one here, this is a quadratic trinomial. I have 3 terms, and the highest degree of this is degree 2. And all the ones you're going to be presented in this are going to be written in standard form. So there's procedures for factoring this. So let's see if you can recall what the procedure is as you factor it, and then we'll go over it. Okay, so when you factor this, now if we looked at the videos that you were given for review, they kind of take situations like this where there's a 1 in front of the x squared, and situations where I have a number other than 1 in front of the x squared, and they treat them differently. There's really no reason to, because it is the same procedure. When I have a quadratic trinomial written in standard form, so if it has this format, ax squared plus bx plus c, we want to find two numbers, integers, n and m, so that n times m equals a times c. That just means that the product of n and m is the same thing as the product of a and c. Doesn't mean it's going to be the same on both sides. It's like if it was like 20, I mean, a and c could be 4 and 5, but the n and m might be 10 and 2. Because the other thing I got to try to figure out is I want to make sure that these two integers also, when I add them together, give me the middle term b. So if I look at this particular instance, and I'm going to go through this one a little bit more as we move on and through this, spend less time going over some of the details. First of all, I'm going to look at having an x squared there in front, having a 1 there. And so when I do a times c, there's a, b, and c. A is 1, b is negative 2, c is negative 15. A times c would be 1 times negative 15, which is negative 15, and b would be negative 2. So I want two numbers that multiply and give me negative 15, but when I add them together, give me negative 2. So I would have to search for them. So I mean, I got to think of numbers that would add and give me or multiply and give me negative 15. 1 and negative 15 would be an instance, but if I add those together, I get a negative 14. So that doesn't work. I have 3 and negative 5. Multiply those together, I get negative 15. And when I do add them together, I do get negative 2. So 3 and negative 5 are the numbers I'm looking for here. Because what I'm going to do now is rewrite the middle term as, instead of just a minus 2x, I'm going to write it as a plus 3x minus 5x. So I'm basically splitting up the middle term, because now I want to do a group and factoring. So what I do is I group the first set together, and I group the second set together. And then what I'm going to do is I'm going to try to see if I can find anything that will factor out of these two groups of 2. So looking at the first one, the one in the green parentheses, if I look at both of them, I can see I can factor out an x from each one of those. So when I factor out the x, I'm left with x plus 3 inside, because x squared divided by x is x, 3x divided by x is 3. In the set of pink parentheses, I can factor out a negative 5. I can factor out a 5 too, but I mean, what I want to do is I want to have whatever's inside this set of parentheses be the same thing as what's in the other set of parentheses. So I'm trying to do my best to move in that direction. And if I do factor out that negative 5, I do get x plus 3 inside the second set of parentheses as well. The reason why I did all this is because of the fact that now I have these two groupings, with both of them have a multiplication of x plus 3. So I'm going to basically undistribute these as well. So when I factor out the x plus 3, I'm left these x plus 3 and the x cancel between above. I'm left with x minus 5. And that's why I could write it as x minus 5, and that's how I end up with that as my final answer. So that's the procedure we use for all of these instances, whether there's a 1 in front or not. It just something's a little bit more simplistic, because a times c, if the leading term is 1, all I'm going to do is look at the last term. When I start getting numbers other than 1 in front of x squared, then I do have to make sure I'm multiplying a and c together. So let's move on to the next one. Okay, for this one, I still have a 1 in front, so I'm looking for two numbers that multiply together and give me 12, which is, 1 times 12, and also added together give me negative 7. I'm not going to list all the numbers that are possible, but cutting to the chase, I find that negative 3 and negative 4 fit that bill. So I want to split the middle term into negative 3x, or minus 3x and minus 4x. It doesn't matter which order you put them in, really. It just, you'll still get out of the same answer, just the factoring will look a little different. So there's different routes you could take with this, but ultimately you should still get the same factors when all is said and done. I'm now going to group them. The first set I can factor out an x, which gives me x times x minus 3. The second group I can factor out a negative 4, which gives me a negative 4 times x minus 3. Now what I'm going to do is I'm going to factor out the x minus 3 they have in common. So this would go, and what I'm left with is x minus 4, which is why that's what ends up over here. And that's the final answer for this. Let's try another one. So for this one here, again, I only have a 1 in front of the x squared, so I'm looking for two numbers that multiply and give me negative 187, but when I add them together, would give me a positive 6. There's a good number. There's several numbers that would multiply and give you negative 187. Not a whole lot, which is nice. And if you look at it, negative 11 times 17 is negative 187, and negative 11 plus 17 is 6. So this is the two numbers I want to use. So I want to split the middle term into minus 11x plus 17x. Now that I have that split up, I can now group these in groups of 2. And out of the first group, I can factor out an x, which gives me x times x minus 11. Out of the second group, I can factor out a positive 17, which leaves me with 17 times x minus 11. again, as I do this, I always want to try to make sure I get these two quantities the same. I mean, these two things should always be the same. If you find out that when you try to do this, that this doesn't work, then you might have the split up. You may have the middle term split incorrectly. You might be dividing incorrectly. There's a whole number of things that could be wrong, but you're definitely doing something incorrect. And again, I can factor this out of both of them. So I'd bring that to the outside, and of course, what I'm left with when I factor that out is, of course, the x plus 17. And that's how I get that factored as well. Let's try this one now. Again, I have a 1 in front of the x squared, so basically c is the number I want my two numbers, my two integers, to multiply together and give me, and I want those same two integers to add up to give me 15. 6 and 9 fit that bill. I mean, they multiply and give you 54, they add together and give you 15. So the middle term is going to be split into plus 6x and plus 4x. Now that I have the middle term split up, I'm going to group them in groups of 2. I can factor out an x from the first group of two terms, so I'm going to have x times x plus 6. I can factor out a 9 from the second group, giving me 9 times x plus 6. And now they both have an x plus 6 in common, I can factor that out. And as you can see, if I factor those out and they would go away, I'm left with x plus 9, which is why I get the second quantity. And that's the answer. Let's try this next one. Well, this one, there is a specific procedure, because this is the difference of squares. And if you remember that, or if you reviewed that, by all means make use of it. But this procedure that you're being shown here that we've reviewed will work with this too. You just have to kind of think of what's going on here. Usually I'm used to having 3 terms here. I don't have 3 terms here. I have the x squared term, I have the constant term, I'm missing the x term. So I can think of this as x squared plus 0x minus 169. So, still having a 1 in front of the x squared, I want two numbers that multiply and give me negative 169, but when I add them together, give me nothing. Well, 13 and negative 13 satisfy those conditions. They multiply and give me negative 169. They add together and give me 0. So those are the two numbers I want to split the middle term into. So I'm going to have x squared plus 13x minus 13x minus 169, which I am now going to group in groups of 2. The first quantity, I could factor out an x, so I would be left with x times x plus 13. The second quantity, I could factor out a negative 13, and what I'm left with is x plus 3 being multiplied to that. Again, I have those two quantities that are exactly the same, the things that are in parentheses, so I can factor that out. And when I factor that out, again, imagining that I'm factoring this out and these go away, I'm left with x minus 13. And so this factors into x plus 13 times x minus 13. And that's the rule for a difference of squares. If you have a difference of two perfect squares, even if there's variables involved, all I got to do is really, and the way it's described is I would, square root the first term, which would be, x squared divided square rooted is x. Square root the second term, and I put a plus in front of one and a minus in front of the other. But that requires me to recognize a difference of squares. One of the giveaways is that you're going to have that 0x term that is never really written there, but I have to kind of know is there. Oftentimes that's the case, and that's lets me know that I might be able to do it that way. So if you know the shortcut, great. If you don't, you can still kind of think of it in the ways we've been doing with these, and still do the same procedure. So let's try this one now. Okay, for this one, still have a 1 in front of the x squared, so I'm just going to look at the last term. I want two numbers to multiply and give me 225, but when I add them together, give me negative 30. Well, that would be negative 15 and negative 15. They multiply together to give me a positive 225, and when I add them together, they give me a negative 30. Signs are very important with this, so I have to make sure that I'm aware of the signage. Sometimes if I have students that will come together and say, well, if I do 15 and 15, I get positive 30, so it's 15 and 15. Well, 15 and 15 is positive 30. We're looking for negative 30. So be careful about signage too. So that means that that negative 30, that minus 30x in the middle is going to be split into two minus 15x's. And I'm going to have x squared minus 15x plus 225, which I now group into groups of 2. The first group of 2, I can factor out an x. The second group of 2, I can factor out a negative 15. And now both of these have the quantity of x minus 15 being multiplied to them. So when I factor that out and get rid of, and these would cancel, I'm left with another x minus 15. So this is x minus 15 times x minus 15, which you'd oftentimes see it being written as x minus 15 squared, because remember, squaring means multiplying something to itself. So that's how you do that one. So now let's get into situations where I would actually have a number in the first position on the leading coefficient that's not 1. So what happens in this instance here, where I have 3x squared minus 15x minus 42? Give it a try and we'll get back to it. Okay, for this, the very first thing that you always try to do with these is, no matter how many terms you see, try to see if there's anything that'll factor out of all three of them, whether they're numbers, letters, or a combination. Here, I can't factor any x's out, but I can. All the three of these are divisible by 3, so I'm going to factor out a 3. So when I factor out the 3, 3 divided by 3 is 1, because I have a 1 in front of the x squared. I usually just don't write it. A minus 15x divided by 3 is a minus 5x. A minus 42 divided by 3 is a minus 14. So now I have a simpler coefficient inside here. And again, I'm going to recognize the fact that this is a 1 in front. With that being the case, again, since I now have a 1 in front, I'm going to focus my attention on this quantity inside the parentheses only. And I want two numbers that multiply and give me negative 14. And when I add them together, give me negative 5. Negative 7 and 2 are numbers that would allow that to happen. So I want to split the middle term inside the parentheses into a minus 7x plus 2x. And so that's what I write inside here. And now inside this first set of parentheses, I'm going to group this 4-termed polynomial into two-termed polynomials. And I'm going to factor each one of these. So I'm going to factor an x out of the first one, which gives me x times x minus 7. I can factor a positive 2 out of the second one, which gives me 2 times x minus 7. Again, like I had before, they both have this multiplication of x minus 7. So I can factor that out. And when I factor that out, again, these cancel. I'm left with x plus 2. And now that I have that factored inside there, I really don't need the extra set of parentheses, because all that's going on here is multiplication. So if I want to write this factored completely, I would just write 3 times x minus 7 times x plus 2. Let's try another one. Now this one's a little trickier, because if you look at 6, they all don't have x's, so I can't factor out any power of x. And 6, 41, and 70 really do not have any common factors. So I can't, make these coefficients any smaller or more handleable. So now I have to just kind of go with the method. So again, 6 is going to be my a value, b is going to be negative 41, and c is going to be 70. So I want two numbers that multiply and give me 420. Which is what a times c is. But when I add them together, give me a negative 41. And as you can see there, of the numbers that would allow that to happen, negative 20 and negative 21 would be the two numbers that would allow both of those to happen. So I want to split this middle term into minus 20x minus 21x. So 6x squared minus 20x minus 21x plus 70 is what I split this into. And now I'm going to group these in groups of 2. Out of the first group, I can factor out a 2x. So when I do, I get 2x times 3x minus 10. Out of the second group, I can factor out a minus 7 or negative 7. And when I do, I'm left with another 3x minus 10. Again, I want this to happen all the time. don't force it to happen if it's not meant to happen. That could just usually mean it's not factorable, but which could definitely happen, by the way. And but for this here, if you're trying to factor, this should happen. That's lets you know you're on the right track for factoring, and it should work out in the end. Now I can factor out a 3x minus 10 out of this, and when I factor out a 3x minus 10, kind of imagine that's gone, I'm left with 2x minus 7, hence this quantity down here. So this becomes 3x minus 10 times 2x minus 7. Give this next one a try. As with the previous example that you worked on, there's no x's that'll divide out of all three terms, and 48, 56, and 15 do not all three of them have factors in common. I mean, if I look at between two of them, I might be able to find some factors in common, but for all three of them, that doesn't happen. So I'm going to have to leave the numbers as is, and considering that 48 is A, 56 is B, and 15 is C, A times C is 720, so I want two numbers to multiply and give me 720, and when I add them together, give me 56. And as you can see, the two numbers that would fit that description would be 20 and 36. So the 56x in the middle is what I want to split into 20x plus 36x, and so I would have this rewritten like this. Now that I have that middle term split up, I'm going to put these in groups. And out of the first group, I can factor out a 4x, which leaves me with 4x times 12x plus 5. Out of the second group, I can factor out a 3, a positive 3, so I had to put that plus sign in front. And that leaves me with 3 times 12x plus 15. Again, I see that I have the same quantity again. It's a good sign that I'm on the right track, because now I'm going to factor that out of both of these groups. And when that gets factored out and canceled, I'm left with 4x plus 3. Hence, that's how I get the second quantity. So this ends up being 12x plus 5 times 4x plus 3. Let's move on to the next one. Now for this one here, I am able to, no x's will factor out of all three terms, but all three of these are divisible by 6. Actually, they're all divisible by 12. I always look for the greatest common factor. I mean, 6 will work, but 12 is better because 12 will factor out of all three of them as well. So if I factor out the 12, I am left with, inside the parentheses, 3x squared minus 5x minus 2. This makes the work I have to do a lot more easily handled, because my numbers are smaller, and the smaller the numbers, the less factors that I have to test and see if they're going to work or not. So it won't go down any further than that. So, looking at A being 3, B being negative 5, and C being negative 2, AC is negative 6. So I want two numbers that multiply and give me negative 6, but when I add them together, give me negative 5. Negative 6 and positive 1 are the set of numbers that would make both of those happen. So I want to split the middle term into a minus 6x plus a 1x. I don't usually write the 1 in front. I can. You might even see that I will do it later for purposes beyond this, but that's why I split it. And now I'm going to group these in groups of 2. As I look at the first group, I can factor out a 3x. I'm left with 3x times x minus 2. And I already have an x minus 2, over there anyway with my second group. I do want to imagine, though, that I do have a plus 1 in front of that. That's going to be important when I do the next step, because my next step is I'm going to factor the x minus 2 out of both of these grouped terms here. And when I do that, again, these would cancel, leaving me with 3x plus 1. A lot of students, they don't write the coefficient there. They treat it as a 0. It's not a 0. It's a 1, because when I cancel something out completely through division, or factoring, which is basically a term of division, I end up with 1, not 0. So I end up with 12 times x minus 2 times 3x plus 1. I don't need the outer set of parentheses, since all I have now are quantities being multiplied together. The other things are occurring inside parentheses. So I can write this as 12 times x minus 2 times 3x plus 1. Let's try this next one. Okay, so if you look at these three terms, they don't all have x's in them, so I can't factor out any x. And all three of them do not have factors in common. Particularly the 9 and the 16. There's nothing in common that they could have together. So I have to leave it as is. So 9 times 16, because that's my A and C values, is 144, and of course B is 24. So I'm looking for two numbers that add together and give me 24, but when I multiply them, give me 144. And as you can see here, 12 and 12 make that possible. Usually when I see that happen, when it's the same number twice, that usually means that I probably have in front of me a perfect square quadratic trinomial in front of me. And you'll see that what I end up with when I do that. They have certain structures that sometimes you can tell them apart, but again, and that's something, one of the other things, other categories that you were given in the lesson. However, again, you do not need to know how to recognize a perfect square trinomial to do this process, because this process works for anything that's possibly factored, whereas the other methods only work under very specific conditions. So, but anyway, I split the middle term into 12x and 12x. I group these in twos. The first group of two, I can factor out a 3x, which gives me 3x plus 4. The second group, I can factor out a positive 4, which gives me another 4 times 3x plus 4. And now both of these groups have a 3x plus 4 being multiplied in it. So when I do that, and again, these would cancel, I'm left with 3x plus 4. So that's why, when I factor the 3x plus 4, I'm left with another 3x plus 4. And since I have something multiplied to itself, I would just write that as 3x plus 4 quantity squared. Let's try another one. Now for this one here, again, if you recognize this as a difference of squares and know how to handle that circumstance, great, do it. However, again, that's a very specific thing that works under very specific conditions. I'm going to still show you here that you can use the methods that we've been reviewing in this video and everything else that you were shown, and still get to the same answer. Just the only tricky part about this when you get a difference of squares is that obviously I'm missing a middle term here. So I need to think of this as 16x squared plus 0x minus 49. Because now, all three of these do not have a term in common. There's nothing, I could divide anything out of 0. But negative 49 and 16 do not have any terms in common. So when I do A times C, I get negative 784. The middle term, of course, is 0. So I want two numbers that multiply give me negative 784, but when I add them together, give me nothing. And I find out that 28 and negative 28 are the two numbers that make that happen. So when I work this out, I'm going to split this up into plus 28 minus 28, plus 28x and minus 28x, I should say. And I'm left with these here. And now I'm going to group these in groups of 2. The first group of 2, I can factor out a 4x. And I'm left with 4x plus 7 after I, inside the parenthesis. The second group, I can factor out a minus 7, which gives me a 4x plus 7 inside the parentheses as well. Now, both of them have that 4x plus 7. Again, that's something we look to have happen. And so now I can factor that out. And when I factor that out, again, they're going to cancel. And I'm left with 4x minus 7. And again, a difference of squares, if you go through the specific rules for those, if you recognize what that is, we could just say, okay, well, the way it usually works is, okay, if I square root the first term, well, 16 is a perfect square. The square root of 16 is 4. The square root of x squared is x. I go to the last term, but the square root of 49 is 7. And all I have to do is make sure to put a plus on one of these and a minus on the other. That's the shortcut procedure for a difference of squares, but it only works for a difference of squares. The issue is sometimes I'll see students who will try to use that on things that are not differences of squares, and that's where problems arise. We have a few more to try before the end of this video, so let's give this next one a whirl. So for this one here, first of all, I'm not seeing quadratic. I'm seeing x to the fifth, which is a degree 5. So it's like, okay, well, this is not going to be handled the same way, at least not initially. But I look at all three terms, all of them have x's in them. So that means I can factor out some power of x. I also look carefully, 30, 90, and 105, they're all divisible by 3. They're all divisible by 5. And I find out they're all divisible by 15. That's the greatest common factor for those coefficients. When I look at the powers of x, the smallest power of x that I see in any one of these terms is x to the third power. So I can factor that out. So 15x to the third would be the greatest common factor of these three terms. And when I factor out these three terms, I'm left with 2x squared minus 6x plus 7. Now that's a quadratic trinomial, so I need to look to see now, well, does this factor, can I factor this, or can I find two numbers that'll work here? A times c would be 14. So I want two numbers that multiply and give me 14, but when I add them together, give me negative 6. And since what we're looking for here are integers, there are no integers that make that happen. I mean, 14 only has a certain number. There's a pretty small number of combinations of integers, at least, that'll multiply and give you 14. I mean, 14 and 1, 7 and 2, none of those, could add up possibly to 6 of some way, even if they're different signs. So this particular instance here, I am not going to be able to factor this any more than I see right now. So this can happen from time to time. You can be given something that has a quadratic trinomial, but that quadratic trinomial doesn't factor any further. Please keep in mind as you know that this can happen. If you're doing a number of problems and you're given, like, if you have exercises that you're doing, or you have stuff that's on a quiz or a test or have you, and you find out that every time that you have a situation where you have a quadratic trinomial and you try to factor, it just doesn't work. It's probably not the case that all of them just don't factor. I mean, you might find one of them does. The rest of them probably should, which means that there's something that you're not doing correctly. So keep that in mind. It's something that will be presented to you from time to time, but it's not going to be a constant thing that happens on every single problem that you try. So let's try this next one. Okay, so again, I don't see the quadratic yet, because I mean I have x to the fourth, x cubed. I have an x squared, but this is a degree 4 polynomial. Whereas, the methods that we're talking about, the AC method, works for degree 2 polynomials. So, but all three terms do have a power of x in them, and all three terms are divisible by 3. So when I look at this, well, the 3 will factor out of all three coefficients. The highest power of x that all three of these have is x squared. So I factor out a 3x squared, leaving me with 6x squared plus 29x minus 22 inside the parentheses. Now this has been broken down a little bit. With A being 6, B being 29, and C being 22. A times C is a negative 132, so I want two numbers that multiply and give me negative 132. But when I add them together, give me a 29. And as you can see up there again, 33 and negative 4 are two numbers that make that happen. The only two numbers that would make that happen. So those are the two numbers that I want to split 29x into. So you're going to see now that inside the parentheses, I'm going to rewrite that with the 29x being written and replaced with a plus 33x minus a 4x. Now I can split this and group these in groups of 2. Out of the first set of parentheses, I can factor out a 3x, and that leaves me a 2x plus 11 that's left over. Out of the second group, I can factor out a negative 2, leaving me with another 2x plus 11 left over. That's a good sign. I want to see that as I'm doing this procedure, because that means that I'm going to be able to factor out that 2x plus 11. Now when I do that, again, when this goes away, I'm left with 3x minus 2, hence that's how I got this. And I don't need the extra set of parentheses anymore because now I have three quantities, 3x squared, 2x plus 11, 3x minus 2, and they're all being multiplied. So I don't need to I don't need to keep having, the extra set of parentheses. So I just write this as 3x squared times 2x plus 11 times 3x minus 2. Also keep in mind that if you're given a problem and these are written in a different order, multiplication is able to be written in any order. So if you had like 3x squared times 3x minus 2 times 2x plus 11, please keep in mind, it's the same thing. And the last problem for this practice exercise. So for this, I can see that they all have powers of x involved. I mean, I could factor out an x out of all three of these. 32, 216, and 280 are all divisible by 8. If you look at 2, 4, those would work too. But 8 is the largest integer that'll factor out of all three of those coefficients. So I factor out the 8x, I end up with 4x squared plus 27x plus 35. And when I assign the A, B, and C values, 4 times 35 is 140. That's what I want the two numbers that I'm going to split the middle term into to multiply to, but when I add them together, give me 27. And as you can see from the selection I show there, 20 and 7 are two numbers that multiply together and give me 140, but when I add them together, they give me 27. So the 27x I have in there is going to be split into 20x plus 7x, which allows me now to group these in sets of 2. And out of these sets of 2, I'm going to factor. So out of the first group, I can factor out a 4x, leaving me with an x plus 5 inside the parentheses. And out of the second group, I can factor out a positive 7, which gives me the x plus 5, again, in the second set of parentheses. I can factor out that x plus 5, kind of undistributing it. And so when I do that, as you can see here, those would go away, leaving me with 4x plus 7, hence that's where we get that from. And that is the final answer for this. If you have any further questions with these, please make sure to get in contact with me, especially before you take the quiz. But until next time, have a good day, everybody.